Well, I think I'll do something anyway. I was wondering, I didn't have a look at the module guide before I came out. Okay, we want to look at non-homogeneous or inhomogeneous. Okay, non-homogeneous. So far, what restriction have we, every time we've had what? Now this time we're looking at non-homogeneous, page 746, okay? We're looking at non-homogeneous or inhomogeneous differential equations, okay? And what do we mean? First thing is I want to explain what we mean by non-homogeneous, and then you'll see that you need a particular integral, an extra bit you need to add on, okay? And how do you find this extra bit you need to add on? So what do we mean by non-homogeneous? So far, what have we had? We had one restriction on the differential equations. What's that been? It's always equal to 0, isn't it? Yeah. So far, we've always had the right-hand side equal to 0. But say if you've not got right-hand side, you know, the one with cos x in, you didn't have 0 on the right-hand side. You may have that, okay? That's a valid differential equation. So let's say we've got something like this now. A, will somebody just be quiet, plus b dy dx plus cy is equal to fx. And this, in this case, where fx is not 0, okay? Where fx is not 0. We want to solve it. Not is equal to 0. It's not equal to 0. This is called a inhomogeneous or non-homogeneous differential equation. Now let's take an example. Solve d2y dx squared minus dy dx minus 2y is equal to 5e to the 4x. So how do we solve this? How would you solve this differential equation? Okay, I'll give you a clue. What you're going to do is like, I don't want to keep talking about linear algebra, it's not right as soon as you don't do linear algebra. So you don't need to know. Sorry, if I do mention linear algebra, I'm trying to put you off. I shouldn't say that, but some stuff we've done, you see, although we've done it with different equations, we've done linear equations, not differential equations. What you do is you find the homogeneous solution, you find the underlying solution. And then you find the extra bit you need to add on. You say, okay, find the underlying solution, okay? You find the homogeneous solution, and then you find the non-homogeneous solution. How do we find the homogeneous solution for this? The same as before, okay? So what we're trying to say to you is that if you've got a graph, okay, we know we've got a non-homogeneous, okay? What you do is the homogeneous solution is the one which goes through 0, okay? It's got 0. Your non-homogeneous is the one which is either, something like that, yeah? So you add, 7 or whatever y, you add the y bit on, yeah? You add that extra bit on there. First, so that's why we find homogeneous. We find the grade which goes through 0, okay? And then we add the non-homogeneous bit on. So the homogeneous, of course, we should be able to do. It's homogeneous is the one with 0 in. Homogeneous, okay? So what do we have? We want to solve this. d2y dx squared minus dy dx minus 2y is equal to 0. How do we solve that differential equation? M squared, yep. Minus m minus 2 is 0, yep. And what else? Well, you're trying to factorize it. What do you factorize it into? Yeah, m minus 2 is okay. And m what? M plus 1. That should do it, shouldn't it? Yeah? M minus 2, m plus 1. So what do I get? Yeah, m1 is 2, and m2 is equal to minus 1, isn't it? Yeah? So, real and different, isn't it? Real and different, yeah? So, what do we have? Y is equal to, ae to the 2x plus be to the minus x, yeah? Now, if you put that into the given differential equation, this solution here, yeah? If you put that solution, okay, this solution, into there, what are you going to get? Say if you put y, you differentiate twice, put it in there, differentiate once, put it in there, leave it alone, put it in there, and if you subtract that, what do you get? What would you get? Sorry? 0. You must get 0, isn't it? Because that is the homogeneous bit, isn't it? We just solved that one, didn't we, yeah? This is what's called the homogeneous or the complementary function. YC, this bit's called, I'll tell you why we call it YC, it's called the complementary function. Okay, now what else do you need? That's not going to be the solution. What you need, if you put this in, you get 0, but we haven't got 0, we've got 5. So you need to add something else onto this solution. That's some of the solution, you know, that YC is equal to, you know, AE to the 2x plus BE to the minus x. But there must be some other bit. There's got to be.
We just add that bit on.
Can we just add that on? We can't just add that on. It may work, it may not. But one thing is clear. What would you add on? What would you trial? It's called a particular integral. What would you want to trial? If you add this on, the problem is that you get minus 10y or minus 10 lots, okay? You get minus 10 lots of e to the 4x. You know, you get differentiate that once, you get, you know, minus 4. You may not get 5 at the end. You want to get 5 lots of those. You want exactly 5 lots. That's the problem. So you can't just try, you know, 5e to the 4x, could you? What could you trial? Sine 4x? Cos 4x? 4x? What could you try? What would you, the obvious thing to trial? I'll give you a clue. It's going to have e to the 4x, but that's what you need. How else are you going to get, if you differentiate e to the 4x, you get e to the 4x, don't you? So it's got to have e to the 4x in there, because you want e to the 4x at the end, don't you? You've got to try that. There's no other choice you got. But what's the one number you're going to trial there in front? Yes, exactly. You don't know what it is, so you put C, yeah? You put C in there, yeah? You don't know what it is, you trial a C e to the 4x. E to the 4x because you've got e to the 4x on the right-hand side. Okay, but you've got 5 lots. If you try 5e to the 4x, it's not going to work. We know that. We just had a quick look and just didn't work. Okay, so you try C. Now, all right, at the moment, so you've got your solution is y is ae to the 2x plus b to the minus x plus ce to the 4x. And that really is a useless solution, isn't it? Why is that a totally useless solution? Go ahead.
You've got 3 unknowns.
3 unknowns, yeah. We had 2 unknowns first, and we know we can't do anything about these 2, because we haven't got no initial conditions. We really can't do anything about them. Unless I give you some initial conditions, you know, I say when t is 0, you know, x is 5, when t is 0, x is 7, dx dt is 7 or whatever, then you can find a and b. But then you still have this one. We need to find the c. How can we find the c? What must this c satisfy? The one that Rob was hinting at earlier on. Can't be any old C. Which C? What must it satisfy? Look at what we want to do. We want to get, if you look at it, we want to get, this is what the solution we're trying to solve that one. So which C, what should it satisfy? Sorry? When we just tried 5, it didn't work. Sorry? Minus 2? Well, minus 2, but then you've got to differentiate as well, yeah? It may not work. Minus 2 is not going to work neither. It may do, but it may not. Can't guarantee. What should you trial? What must this... Forget this. Forget that. Forget this bit. This gives you 0, yeah? You know if you put that, you got 0. You need 5, yeah? You need 5. 5 lots of those, yeah? You need 5 of those, okay? So what you could do is put it in there, yeah? Differentiate, put it into there. Sorry, you can't see it, I didn't realise. Differentiate, put it into there. Differentiate twice, put it in there, can't you? You can do that, couldn't you, yeah? See which C satisfies that, yeah? Okay? And then equate to 5e to the 4x. So if we say y is equal to ce to the 4x, then you differentiate once, dy dx, what do you get? You differentiate this once, what do you get? Yeah. 4ce to the 4x, and if you differentiate again, d squared y dx, so what do we get? Yeah, 16ce to the 4x, yeah? Alright, so we end up with, remember we want to find d squared y dx squared minus dy dx minus 2y is equal to 5e to the 4x, isn't it, yeah? That's what we need, okay? Now d2y dx squared is 16c, isn't it, yeah? So 16c e to the 4x minus 4c e to the 4x minus 2c e to the 4x, and all that must equal 5e to the 4x, mustn't it? Yeah? That's got to equal 5e to the 4x, because that's the differential equation given to us. How can I find c now? Sorry? Well, you can take e to the 4x out, can't you? Yeah? If you take e to the 4x, factor out e to the 4x from both sides, what do you get? 16c minus 4c minus 2c e to the 4x is equal to 5e to the 4x. How does that help us find c? How many c's are there? Sorry? 10, yeah, 10c, isn't it? 10c is equal to what? Must equal 5, mustn't it? Yeah, 5, okay? E to the 4x, either multiply by or divide through by e to the 4x, yeah? Go on, Charlie.
Essentially, c is the half.
Yeah, c is 5 over 10, which is c is a half. So our solution, that y that we tried, okay, y, is, we tried c e to the 4x is equal to half e to the 4x. So our general solution, okay, so far is going to be y, okay, the homogeneous bit, the complementary function, yc, plus the extra bit we need to add on, yeah, to get the 5e to the 4x. We couldn't try 5e to the 4x, it wouldn't have worked. Half worked. Tavik said minus 2. We could try minus 2, it wouldn't have worked, but half definitely worked. But we didn't know that, didn't we? We didn't know it was a half. We had to work it out it was a half, didn't we? We had to do equate it, didn't we? To get that value, what number is it? So we've got y is equal to yc, so this was equal to ae to the 2x plus be to the minus x plus half e to the 4x. So that's your general solution to that. Oh. Please shout if you can't see. I just noticed looking on there that you couldn't see it. So when you do have, the procedure for this, okay, is when you have a second order non-homogeneous differential equation, okay, fx is not 0, you first solve the homogeneous, you first find the underlying solutions, okay, you first find that, and then you try that particular function. I'll tell you, there's a formula in the maths handbook, but I don't even use the formula. I want you to get away from formulaic, learning formulas. A lot of students, if you ask them to solve a quadratic, they use the formula, and you go, what are you using a formula for? Well, I know it's much harder to sort of factorize things like that. I just don't want you to get it. If you do formulaic, you can get anybody, you can get any A-level GCSE student to put numbers into a formula and put them into your calculator and see what it throws out. Anybody can do that. I want you to know what's going on. That's more important. Not apply this formulaic approach, although you are given the formula for this, the particular integral of the y. I would I'll tell you how you can find this. So what you do is you first try the complementary function, then you trial, y is it, you trial y, okay? And you look at the right hand side, see what fx is, yeah? Okay? And then your general solution is the complementary, the homogeneous plus the extra bit, yeah? Sorry, you can't see. It's that plus the extra bit, yeah? Now, how do you know what to try? Well, what happens, it depends on your right hand side. Let's do another one. If you get, let's do, what do you determine? So, determine the particular integral for d2y dx squared minus dy dx minus 2y is equal to 2x, yeah? So what I've done in this case is the same as the last example. It's the same example, okay? Except last time I had on the right hand side, I had 5e to the 4x. I've changed that to 2x. That's what I've done. Same example. So the left hand side, the homogeneous bit is going to be the same. Now what should you trial? What sort of function is that? What is that? If you graphed it, what does it look like? Yes, a linear function. So what you try the general linear function. Okay, so your particular integral y would be not just ax, but ax plus b. Okay, or cx plus d. Okay, you try ax plus b. It's a linear function, straight line. Okay, you try ax plus b. Now, how do you find the values of a and b? This is the extra bit you want to add on. The left-hand side is going to be the same as last time because it's the same differential equation. The only thing which has changed is the right-hand side. I've changed that from 5e to the 4x to 2x. Well, some of you should really complain about this room. Because I'm going to call this extra to hot soon anyway. So cold in here. Yeah. But, you know, I was just even thinking, should I actually start this or not? I thought I'd start something. How do we find a and b? Sorry? Yeah, differentiate, yes. Differentiate it, put it in there, differentiate it twice, put it in there, yeah? Okay? So we get dy dx. If we differentiate that once, what do we get? A, yep. And if we differentiate this twice, what do we get? 0, okay? So if we put it into here, we get 0 minus a minus 2 times ax plus b is equal to 2x, isn't it, yeah? Okay, that's what we get. Minus a minus 2a x plus b, isn't it, yeah? Is equal to 2x. Okay, how do I simplify this? I want to find the values of a and b. Oh, they've got too many unknowns. How can I find the values of a and b? What's the obvious thing to do on the left-hand side? Yep.
When you put it into what, maybe firstly take it so you get the bracket.
Yeah, expand the brackets. Yeah, I would do that. Minus a minus 2ax minus 2b is equal to 2x. Okay? But how does that help me to find a and b? Have you done this before? Or something like this? Have the confidence. Yep. So listen. Either Charlie or Hannah, I don't mind.
You can put the 2ax onto the other side by...
No, that wouldn't help you. Yep. Yeah, equate coefficients, exactly. Equate coefficients. Equate coefficients. How many x's on the left? How many x's are there on the left? Yeah, minus 2a. How many x's on the right? 2, yeah. So a is equal to what? What's a equal to? What's all this noise? Minus 1. A is equal to minus 1. All right. How do we find b then? That's not how you find b, is it? How do we find b?
Minus a minus 2b.
Yeah, minus a minus 2b is equal to 0, isn't it? Yeah? Minus a minus 2b is equal to 0. A we just found is minus 1, isn't it? Yeah? So minus 1 minus minus 1 gives you what? Plus 1. Yeah, we've got 1 minus 2b is equal to 0. So 1 is equal to 2b. So b is a half, isn't it? B is a half. So your trial function is what? Or your particular integral is what? Y is equal to what? What's it going to be here? I tried ax plus b, a linear function. What do I get? What do I get? Come on. Yeah, minus x plus a half, isn't it? That's going to be my trial function, isn't it? Okay? Let me just do one more, and then we definitely will call it a day. Let's just do one more. Say if you've got the same differential equation, I change this to... So I've got the left-hand side the same. d2y dx squared minus dy dx minus 2y is equal to, let's say, 5x squared. I want to solve that one now. How do I do this then? Yep. Sorry, I want to find the particular. I'm only interested in the particular integral. The complement is going to be the same. Yeah.
So you use a quadratic.
Yes. Yes. You use a quadratic, a general quadratic, not just ax squared, but general quadratic. Yeah. How do you write the general quadratic? You try y is equal to what? Go on then. Yeah. Plus ax squared plus bx. That's a general quadratic. C, isn't it? Yeah. Okay. So how do we find? We've got to find the values of a, b, and c. How do we find the values of a, b, and c? Sorry. Yeah. Differentiate. Okay. dy dx. What do we get? If we differentiate this, what do we get? Yeah. 2ax plus b. Differentiate again. If we differentiate again, what do we get? Yeah, 2a, yeah? Well, how do we find the values of a, b, and c? How do you find the values of a, b, and c? Go on, Hannah. Yeah, substitute them back into here. So we get 2a, yeah? d squared y dx squared is 2a. So it's 2a. The minus there, look, minus. So minus dy dx, which is 2ax minus b, minus 2 times y, isn't it? This one here. Minus 2ax squared minus 2bx minus 2c is equal to 5x squared, isn't it? Yeah? All that's got to equal to 5x squared. All right. How do I find each of these a, b, and c's? Yeah, can we simplify anything on the... Let's look at the x's together, yeah? X squared, we have minus 2ax squared, haven't we? Yeah, that one there. Okay, what are the b's? We have, we can have minus 2a plus 2b x, haven't we? Yeah, that one and that one, haven't we? Yeah, and what else have we got? Plus 2a minus 2c is equal to 5x squared, haven't we? That's what you get, yeah? Which I've done it right.
Wait, what's the b?
I've got a b, what?
You forgot the b.
Yes, there's a b missing, isn't there? Minus b. 2a minus b. Was that a mistake by me?
Oh, yeah.
Patrick is arguing. He thinks I can make mistakes. I told him I'm infallible. He doesn't believe me. I don't know why. All right. How do we find A, B, and C now? Come on, we done the technique we did last time. Yeah, equate coefficients. Okay, equate coefficients. What about the first one? Yeah, minus 2a is equal to 5, isn't it? Number of x squares on the left, okay? X squares on the left is minus 2a is equal to 5, which gives you a is equal to what? What's a equal to? Yeah, minus 2.5 or minus 5 over 2 or 2.5, yeah? Okay, how do we find b?
Is that going to be like minus
Yeah?
2a?
Yeah, minus 2a.
Minus 2b
b, yeah.
equals to 0.
Equals 0, exactly, yeah. No, there's no x's on the right, okay? And we know what, so if you work that b, you work this out, you've got b, okay, is equal to, and if you take 2b, b is equal to minus a, isn't it, yeah? B is equal to minus a, yeah? B is equal to minus a, so it's equal to 5 over 2, yeah? Okay, if you take 2b to the side, so b is equal to minus a, and b, a is minus 5 over 2, so it's minus minus going to be plus 5 over 2. How do we find c? How do we find c? Yeah, 2a minus 2c minus b is 0, isn't it? Yeah? Okay, I've got values for a, minus 5 over 2, b, plus 5 over 2, so we've got 2, minus 5 over 2, minus 2c, and b is minus 5 over 2, isn't it? Is equal to 0. And if you miss that, you should be able to do it. You'll find that c, where is it? C is equal to minus 15 over 4. C is equal to minus 15. Or just put the values of a, b, and c, and you can work out what c is, yeah? So what's your particular integral? What's it going to be? What are you going to add? It's y is equal to ax squared plus bx plus c. So what's it going to be? What's it going to be?
minus 5 over 2x.
Yeah. A is minus 5 over 2. Look, there it is, yeah? So it's minus 5 over 2x squared. Yep, go ahead.
Plus 5 over 2x.
Plus, yeah, B is 5 over 2. Where is it? B is 5 over 2. Plus 5 over 2x, yep.
Minus 15.
Yeah, minus 15 over 4. So that is your particular integral, isn't it? Yeah? That's going to be your particular integral. Okay, I'll have to see you. Have a nice break. I'll see you when. 5th. So do not come next week or the first week back. Not even the 8th. It's from 15th onwards, yeah? And did you say it's Thursday morning, 9 o'clock? Oh, what did they do that for? I don't know why they did that.